Welcome to lesson 6.3. In this lesson, we will continue to work with 3x3 systems of equations, 3 equations, 3 variables, but we're going to learn a new method to solve those. Namely, this method is our upper triangular form method, and it looks like this. You can see where it gets its name, this upper triangular form. The reason we like upper triangular form is it's really easy to solve from here. I can get z. Then you can plug z into this one to solve for y. Then you can plug y and z into that one to solve for x. So upper triangular form is really helpful. And basically we have zeros right here. And that's what makes it that upper triangular shape. This is sometimes also called triangular form. Now, we're going to work on this first problem by getting it into upper triangular form. But we're going to start to get a little lazy with it, get a little faster. And the way we're going to do that is through an augmented matrix. An augmented matrix is a new way to write a system of equations, and it's basically helping us write it faster. So we can start to get quicker at this process. We don't have to write out so much work. So let's practice an augmented matrix first with this example. Here's how an augmented matrix works. We first have our matrix bars on either side. We're going to do a line right here. That line is where our equal signs are in our system of equations. So to the right of that line, I'm going to put the numbers that are my answers, 3, 16, and 5. To the left of that line, I'm going to put the coefficients of the equation. So here my coefficients are 3, -1, and +1. So 3, -1, +1. Here I have 2, -4, +3. And finally I have +1, -1, +1. And that's an augmented matrix. So basically we're writing out the same exact system of equations, but we're leaving out all the letters so we can start to write it faster. That's the goal of an augmented matrix. It's just a lazy way of writing a system so you can start to write it quicker. Now, here's what we're going to do in this problem. We're going to get this augmented matrix into triangular form. Basically meaning I want to get zeros here, here, and here. Because then I've got that upper triangular shape. To do that, we have 3 different things we can do. First, we can interchange the position of any 2 equations. So if there are 2 equations that we would like to flip places, we can do that. We can take any 2 equations in this system, flip their places, and it's still going to be okay. Second thing we can do, we can replace any equation with a non-zero multiple of itself. So this is kind of what we were doing with elimination, where we were multiplying one whole equation by a number to get it to eliminate. We can eliminate one variable and replace it back in. And we're saying it's the same thing. So basically, I could take this whole line times everything by 2 and still write that in as 2, -2, +2, +10. And I can replace that line with the multiple of itself. That's totally fine. Third thing we can do, and this one is the most helpful, this is elimination. We can replace an equation with itself plus a multiple of another equation. So we can have one equation, one of our lines, so it's like this line, plus a multiple of this line, and I can replace either line with the answer from that. Basically, this is elimination that we're talking about. So here's what we're going to do. We're going to use those 3 different steps to get this augmented matrix to look like upper triangular form. Now, I'll warn you right now, getting those zeros in the right place can be a little tricky, because if you don't add the right equations in the right order, you're going to get lost really quickly. So in this problem, I am going to detail the steps that we're going to take to get the zeros in the right place, in the right order. So step 1. Step 1 is to get the 0 right here. That is your first step, is to get that 0. Here's what you're going to do. You're going to take the first row, row 1, and you're going to take the second row, row 2, and do elimination on the first variable. Or the first column. Let's write it, say column instead. So I'm going to take row 1 and row 2, 3, negative 1, 1, there's my line, 3, 2, negative 4, 3, 16. And I'm going to do elimination on the first column. Now, right now, I can't eliminate the first column. They don't stack up correctly. So I'm going to times this one by negative 2. I'm going to times this one by a positive 3. So then those things will stack up like I want to. So let's multiply those, see what we get. This one's a negative 6, positive 2, negative 2, line, negative 6. This one's a positive 6, negative 12, positive 9. And 3 times 16 is 48. And now we're going to do elimination on this. So those two eliminated, just like I did, elimination on the first column. 2 minus, so that's going to give me my 0, which is where I wanted it to be. I wanted it to be in that first spot. 2 minus 12 is negative 10. Negative 2 plus 9 is 7. And negative 6 plus 48 is 42. Now, remember, I can replace one of the two equations that I just used, so one of these two, with my new answer. I am going to specifically replace second equation, row 2. So I'm going to take this answer and I'm going to replace row 2 with this answer. That's part of our steps to make sure this works out every time. So I'm going to write out my new matrix. Remember, the first and the third equations will stay the same. We'll replace R2, the second one, with this answer. So 3, negative 1, positive 1, 3. And the bottom one stays the same. And then I'm replacing the second row with this one. And now you'll see I have my first 0 in the right place. Ta-da! So let's move on to step 2. Step 2 is to get this 0 in the right place. So to do that, here's how I'm going to do it. I'm going to take row 1 and row 3 this time. And I'm going to do elimination on the first column. And then I'm going to take the answer from that elimination, like we did here, and I'm going to replace row 3 with that answer. So whatever answer you get from your elimination, replace row 3 with that answer. Now that we've done one, I would like you to pause the video and try this one. So take the first row and the third row, and do elimination on the first column, and then replace the third row with that answer. So pause the video, try that process on your own, and then come back to check and see how you did. Let's see how you did. So I times this one by negative 3, so I get my first column to do elimination. That's what I ended up with. Those eliminated. This is what I ended with. And I replaced the third row with this answer. So the first 2 rows have stayed the same. The third row got replaced with that answer. And now you'll notice I have 2 zeros in the right spot. So I only need one step left. I need to get a 0 right there. So to get a 0 there, here's what you're going to do. You're going to take row 2 and row 3. And do elimination on the second column. This time, not the first column. And then you are going to take that answer and replace row 3 with it. So, same as last time, I want you to pause the video. You're taking row 2 and row 3. And you're doing elimination on the second column now. And whatever answer you get with that, replace row 3 with that answer. So pause the video again, try this step out on your own, and then come back to check. Let's see how you did. I did elimination on my second column, so I times the bottom one by 5 to get those to eliminate. And then I took first 2 lines, stayed the same, took the third line and replaced it with that answer to get this. So this is now what I have. I copied it down up here, and you'll notice that this is now an upper triangular form. I've got zeros here, and I've got my upper triangle. So now that this is an upper triangular form, I can solve this. Now this is kind of easier to do if you put the letters back in. So I'm going to put the letters back into here. So I've got 3x minus 1y plus 1z equals 3. That's a 0x, so negative 10y plus 7z equals 42. And 0x is 0y's, negative 3z equals negative 18. And we can now solve this. So we can solve for z, plug z into here to solve for y, plug y and z into here to solve for x. I'm going to have you pause the video and try this part on your own. Solve for z, and then do the backwards plugging in to solve for y and for x. Pause the video and try that out, and then come back to check your final answer. Let's check what you got with what I got. I got z is 6. Plug that into the middle equation to get y equals 0. Plugged both of those into the top equation to get x is negative 1. So there's my final answer. Because it is a single point that they all share in common, this is a consistent independent system. So that is your first example of solving a system of equations using an augmented matrix, getting it into upper triangular form. And to do that, remember, we always do these 3 steps. You can follow these 3 steps and you will always end in an upper triangular form. So now that we've done all of that, we'll move on to the next video where we'll introduce some new vocabulary and do another example.